just as a quadratic can be written in standard or factored form, other polynomial equations can be written in standard or factored form. Here is a function written in the two different forms. So it says, during this lesson, you'll develop techniques to sketch the graph of a polynomial from its equation. So this is called the Mathematical Carnival Company has decided to build a new roller coaster to use at this year's county fair. The new roller coaster will have special feature. Part of it will be underground. The designers will use a polynomial function to describe different pieces of track. Part of the design is shown at the right. Your task is to guess a possible equation and test it on your graphing calculator. So, and it says, think about how the graphs are the same by testing some of these different functions. You also know the x-intercepts, and you can kind of see their multiplicity on the graph. So it says your task is to use the information in these hints. None of these are the perfect equation. And basically what you already know about multiplicity, and come up with an equation for this graph. Y equals blah, blah, blah. And you have zeros that we just talked about, right? How to take a zero and write a factor. You know things about multiplicity. I want to see if you guys can come up with the equation that would model this shape. And you've got your calculator, a partner, and I'm going to walk around and see if I can give you some help. And I would start by plugging in, these functions. If you plug that into your y equals menu, let's do that first one together. We're plugging in x times x minus 2. Right, so if I plug x times x minus 2 in and graph it, I'm going to think about, how does this graph have correct pieces that this graph has? Oh, well, it's got, 0 as one of its x-intercepts that cuts through. That side of the graph looks pretty perfect, right? But the rest of the graph is incorrect. So make a mental note and then try like the next equation and see how that is good. And then try the next equation. How is that one good? I want to see who can come up with the equation of that polynomial function. We're trying to get this graph up here. No, none of these are. Oh, all right. So I know to have an x-intercept at 0, I need a factor of x, right? That's what does it for me, is the factor of x. I know to have a factor that's going to produce 2 as an x-intercept, I need x minus 2 to be a factor. To get 3 as an x-intercept, I need x minus 3 to be a factor. Remember, your factors are opposite what your x-intercepts are going to be. We just talked about that on the other page. There is one thing that's wrong with this. We've talked about multiplicity. This one cuts through the x-axis. This one bounces off the x-axis, and this one cuts through the x-axis. All three of these currently are to the first power, meaning that they are odd multiplicity. Odd cuts through. So I only need to make one change on multiplicity. Which factor needs to get changed? Where do I want it to bounce off? I want a little, see how there's a little parabola there at 2 bouncing off? You need to change this to the second power. See how these different examples showed you some different pieces that you needed? This is what they wanted you to get to. So x times x minus 2 squared times x minus 3. When I graph it, it comes out similar in curvature to this function. I can't see what the turning point is, but do you see how that's where we're trying to get to? What's the factor and what's the multiplicity? So on the next page here, you're going to examine this polynomial. Let's do this one together since it seems like we're struggling with this. All right, what family of functions is this a member of? So that's linear, quadratic, cubic, quartic. What's the total degree of the whole function? Cubic, right? X times x squared. So it's cubic because it's third degree, right? X times x squared is x cubed. And then it says, based on the equation alone, sketch the shape of its graph. So this is exactly what you have to do on the homework. You have to sketch, okay, where are the x-intercepts? what's their multiplicity, and what's the end behavior. You're putting together 3 pieces of a puzzle. So you have to, I guess, memorize how to do the puzzle. Give me my 2 x-intercepts. +2. I put a dot at +2. -5, right? We're still using information from last unit, but I'm not making you get it to factored form. It's in factored form. You should be able to read those factors like light bulbs. Oh, 2. Oh, -5. All right, now, what's the leading coefficient of this whole problem? +1, right? If I multiply this out, -2 is going to affect the constant, but it's not going to affect the leading coefficient. The leading coefficient of all the x's is going to be +1. All right, so the right side of the graph is going to go up. So I draw an upward arrow from the right side of the graph. You just told me the degree was 3. What's the left side of the graph going to do? Down, because 3 is odd degree. They go in opposite directions, odd opposite. Now I need to curve this guy around. Where's it going to bounce off and where's it going to cut through? Bouncing off at -5, right? X plus 5 squared. So I can draw a little parabola right there. I never found what the y-intercept was, but somewhere negative land. And then it's going to curve up through the other x-intercept. And then it says, use your graphing calculator and read the graph. All right, so we just kind of graphed it without using a calculator. All right, could you try example 3 kind of the same way? It's asking you about what are the x-intercepts, sketch the graph. All right, so you are going to try example 3 kind of the same way. How many different factors does it have? I would just count it as having 3 different factors because this 2 in front is just stretching the graph, right? So it has 3 different factors, right? So what are the x-intercepts? Graph it. How does the 2 affect the graph? See if you can answer those questions for him. It says, how many x-intercepts? We know there's going to be 3 of them, right? So when I sketch my graph, I should have an x-intercept at -2, +2, and +3. Is that what you said? +2, -2, +3 are my x-intercepts. So I just need to sketch the graph with the end behavior, right? The right end has to go up because 2 is the leading coefficient, and that's positive. The degree was 3 odd, x cubed. So this side goes down opposite. Cut through, cut through, cut through, because they all had odd multiplicity. So cut through, cut through, cut through. Should look something like that. And it says, how is it similar or different to the first equation up here? I mean, they both were, what, odd degree? This one only had 2 x-intercepts with a bounce off. This one had 3 x-intercepts with 3 cut-throughs. You don't have to really write that much right now. It's just kind of thinking about how to graph. And then it said, did the factor of 2 affect the x-intercepts? No. The only thing it's affecting is the steepness of the graph, but it says, what would happen if it changed to a -2? The 2 sides would go in the opposite directions, right? It would now go down on the right and up on the left. So down on right, up on left, like basically flipped, right? Because now the right side goes down for a negative coefficient, but odd opposite, this would go up. All right, and then I'd like you to just throw that last equation into your calculator. I can't determine any x-intercepts because it's not in factored form, right? So it just says, use your graphing calculator, figure out what the intercepts are. It doesn't say that you have to graph it, so just x equals, why don't we just write down what the x-intercepts are from the graph? So see if you can graph it. This is the graphing strategy that we learned last unit. X to the 4th minus 21x squared plus 20x. If it's x to the 4th, there could be 4 x-intercepts, but there could be fewer than 4 x-intercepts. You're on the lookout for the x-intercepts. So I want to hear from you. How many x-intercepts are there? And I'm not going to put that part in the video because I want people that weren't here to actually have to graph this.